Welcome students. Chapter 5th, Coordinate Geometry, first part, where we will be seeing distance formula and the first question of practice set 5.1. The distance between any two points on a number line is the topic which we will revise right now. We know how to find the distance between any two points on the number line. If the coordinate of point P, Q and R are -1, -5 and 4 respectively, then we are supposed to find distance PQ and distance QR. Now, see the number line. It is given that coordinate of point Q is -5, coordinate of point P is -1 and coordinate of point R is 4. If x1 and x2 are the coordinates of point A and B, where x2 is greater than x1, then the length of segment AB, which is also written as distance AB, is given by x2 minus x1. This we have studied in the lower classes. Now, as shown in the figure, coordinate of the point P, Q and R are -1, -5 and 4 respectively. So, P, Q, this one, -1 is bigger, -5 is smaller. -1 minus from the formula -5, which is given as -1 plus 5, which is equal to 4. Distance Q, R. You can see here this is 4. This is -5, 4 is greater than -5, therefore distance QR is 4 minus from the formula -5, which is equal to 4 plus 5 equals 9. Using the same concept, we can find the distance between two points on the xy plane. Our distance formula will be applied to find distance between two points in the plane. Let us see. First case, to find the distance between any two points on x-axis. We know this very well. On number line we were knowing, same logic is applied on x-axis. In the above figure, point A is x1 and 0 and point B is x2 and 0 are on the number line, and that also x-axis, such that x2 is greater than x1. Distance AB is given by x2 minus x1. So, any line, if it is considered as x-axis, the distance between point is given as x2 minus x1. Any line parallel to x-axis, similar way, we get x2 minus x1. We will see this in detail later on. Now, to find the distance between two points on y-axis. This is your x-axis, this is your y-axis. Two points are on y-axis, P and Q. You are supposed to find the distance between them. P is 0, y1, Q is 0, y2. y2 is greater than y1. Above figure, 0, y1 and 0, y2 are the coordinates of point P and Q, and that these 2 points are on y-axis, such that y2 is greater than y1. Distance PQ is given by y2 minus y1. Now see this. Again same thing. Now a line, we have seen it on x-axis. Now this line is just above the x-axis, parallel to it. This distance we are supposed to find. Here it was 5. Here it is 1. 5 minus 1 is 4. If it is written x2, x2 minus x1. Let us call it as A. The point here is x2, y1, x2, y2. Don't get confused with all this. Always go and see it is parallel to which axis. It is parallel to y-axis. If it is parallel to y-axis, that means this coordinate is y2, this coordinate is y1. This distance is given by y2 minus y1. This distance is given by x2 minus x1. This is called as A. This is called as B. Let us call this as C. We will see this in more detail so that there is no chance of confusion for you. With number line, we had seen this. If the point is here, PR or PQ, we subtracted the smaller number from the bigger number. Same logic goes here. Smaller number is subtracted from the bigger number. In this chapter, in distance formula, we apply distance between the points on the number line, that concept, and Pythagoras theorem. Let us see that in detail. But before that, let me tell you, if you have some difficulty in this topic, please go and refer Basic Concepts of Geometry Exercise 1.1 Part 1 Maharashtra State Board done. Video done by me. The link is shared with you here. The link will be shared in the description too. Now see this. This point parallel is -3. This line parallel to x-axis. This point is 2. Distance, this distance, 2 minus of -3. How? Bigger number is 2, minus from the formula, -3 is equal to 5. Similarly, bigger number is 3, line parallel to y-axis. Bigger number is 3. 3 minus from the formula, -1 is equal to 4. So, this distance is 5, this distance is 4. A is 5, B is 4. Let us see one more example. This point is -1, 2. This point is 3 and 5. And our target is to find distance between these 2 points. Target is find the distance between the green dots. You can see a green dot over here and another green dot over here. First let us find what is B, what is A, and we will see. The length of leg B is calculated by finding the distance between the values of x coordinate. Here x values of the given point. Here the x value is -1. Here the x value is 3. -1 is smaller than 3. Right? Okay. Next one. The length of leg A is given by difference between the values of y. Let us see that in detail. A. Why it is called leg A and leg B? Actually, a right angle triangle is formed, and this line are also called as legs of the right angle triangle. Now, distance A, bigger number 5 minus 2 is equal to 3 units. This distance B, 3 minus of -1, 3, here 3, 3 minus from the formula, -1 this coordinate, 4 units. So, what we have received? We have received distance A and distance B. Our target is to find distance C. Just think about it. Yes, use Pythagoras theorem to find the length of hypotenuse. You can use it. One distance is 3, A is 3, B is 4, A is 3, B is 4, C is to be found. Just use Pythagoras theorem. C is given by square root of 3 square plus 4 square. That is 9 plus 16, which is coming out to be 25, equals to 5. And we reached our answer. The distance between 2 points is 5 units. Writing units very important in examination. Distance formula. As I already said, distance formula is nothing new. It is just an application of two concepts which you have learned in the lower classes. One is distance between 2 points and the other one is application of Pythagoras theorem. What do we do here? We see here in right angle triangle ABC, A is given as x1, y1 and B is given as x2, y2 are the 2 points in xy plane. What is xy plane? When x and y axis are taken together, it becomes xy plane. From point B, draw a perpendicular BP on x-axis. From point B, draw a perpendicular on x-axis. Call it as BP. Clear? Okay. Now, BP is parallel to y-axis. BP is parallel to y-axis. When it is parallel to y-axis, the coordinate of point D is, coordinate of point P is x2. Because the equation of this line is x is equal to x2. If you still have doubt, please refer Coordinate Geometry of 9th standard. Link will be given in the description. How to plot the point, Coordinate Geometry of 9th standard. Now, segment AD is parallel to x-axis. AD parallel to x-axis. Distance AD is equal to x2 minus x1. Distance BD is equal to y2 minus y1. Apply Pythagoras theorem. AB square is equal to AB square is equal to AD square plus BD square. AD is nothing but x2 minus x1. BD is nothing but y2 minus y1. So, AD square, you are writing x2 minus x1 the whole square. For BD square, you are writing y2 minus y1 the whole square. And you reach to your required distance formula. Distance AB is given by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So what is the formula that is used to find distance between 2 points in xy plane is given by x2 minus x1 the whole square plus y2 minus y1 the whole square. Before solving the problems, we should remember this. The coordinate of origin is 0, 0. Hence, if coordinate of point P are x, y, then distance OP is given by x1 square plus y1 square. The coordinate of origin is 0, 0. Hence, if coordinate of point P are x, y, then distance OP is given by square root of x square plus y square. Directly apply. Second one, if point P is x1, y1, Q is x2, y2, these 2 points lie in xy plane, then distance PQ is given by x2 minus x1 the whole square plus y2 minus y1 the whole square, which is also equal to PQ square is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. Let us understand once again what we have done. One of the point is 2 minus 3, the other point is 7 and 2. first step what you do is x2 minus x1. This is the point, right? x2 is 7, x1 2, x2 minus x1 is 7 minus 2, which is equal to 5. y2 is 2, y1 is minus 3. So 2 minus from the formula minus 3 is equal to 5. Apply distance formula, x2 minus x1 the whole square plus y2 minus y1 the whole square. Put the values, 5 square plus 5 square, that is equal to 25 plus 25, which is given as 50. Nothing but 25 into 2. Find the distance between point minus 1 and 1, P point minus 1 and 1, Q point 5 and minus 7. Suppose the coordinate of point P is x1, y1 and coordinate of point Q is x2, y2. x1 is minus 1, x2 is 5, y1 is 1, y2 is minus 7. So what you get here is, first step is write x1, y1. पहले suppose करेंगे उसको. Then you will write separately every point. Then you will apply the formula. According to distance formula, distance PQ is given by x2 minus x1 the whole square plus y2 minus y1 the whole square. Square root of, substitute the value. x2 is 5 minus from the formula minus 1 the whole square plus minus 7 minus from the formula 1. So 6 square plus minus 8 square. Everything inside square root. 6 square is 36. 8 square is 64. Add them, you get 100. Square root of 100 is nothing but 10. So distance PQ is 10. Don't leave your answer over here. You are supposed to write there. Therefore, distance between point P and Q is 10. Now, we will start with practice set 5.1. In this part 1, we will be dealing with the first question. Here, let A is given by x1, y1 and B be given by x2, y2 be the given points. x1 is 2, y1 is 3, x2 is 4 and y2 is equal to 1. From where I got this? From the question. Now, by distance formula, distance AB is x2 minus x1 the whole square plus y2 minus y1 the whole square. Substitute the value. x2 is 4, x1 is 2, 4 minus 2 the whole square plus y2 1, y2 is 1 minus 3 minus from the formula. So this is 2 square minus 2 square, that is 4 plus 4, which is equal to square root of 8, which is nothing but 2 root 2. The distance between point A and B is 2 root 2. Last answer is very important. See the next question. P is x1, y1, Q is x2, y2 be the given points. P is x1, y1, Q is x2, y2 be the given point. x1 is minus 5, y is 7, x2 is minus 1, y2 is 3. So, write the formula. Distance between the point PQ is given by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Substitute the value. After substituting the value, we get that x is equal to minus 1 minus from the formula minus 5 the whole square plus 3 minus 7 the whole square. Once you do this, you get minus 1, minus into minus becomes plus 5 whole square plus 3 minus 7 the whole square. So ultimately minus 1 plus 5 is 4, 3 minus 7 is minus 4, that is 16 plus 16, which is equal to 32. Last answer, very important. Distance PQ is 4 root 2. The distance between point P and Q is 4 root 2. Next, third question. x1 is 0, y1 is minus 3, x2 is 0, again y2 is 5 upon 2. Not to worry, the first step, you are writing first in the solution. Remember, let, suppose करो उसको, ये statement भूलने का नहीं एग्जाम में. By distance formula, distance RS is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. 0 minus 0 the whole square plus 5 upon 2 minus of minus 3 the whole square. 0 minus 0 is nothing but 0. 5 upon 2 minus into minus becomes plus 3 the whole square. What you get is 5 plus 6 upon 2 the whole square, which is nothing but square root of 11 upon 2 the whole square. This square root and this square will get cancelled. What you get here is the distance between point RS is 11 upon 2 units. Fifth question. I expect you to solve this by yourself. Sixth. x1 is minus 7 upon 2, y1 is 4, x2 is minus 11, y2 is minus 4. Let w be x1, y1 and x be x2, y2 be the given points. x1 is equal to minus 7 upon 2, y1 is equal to 4, x2 is equal to 11, y2 is equal to 4. The distance formula is given by distance wx is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. Substitute the value. x2 is 11 minus from the formula x1 minus 7 upon 2 the whole square plus y2 is 4, 4 minus 4 the whole square. So what we get is 11 plus 7 upon 2 the whole square. When you get this, your required answer is take the LCM. 11 into 2 is 22 plus 7 upon 2 the whole square. 22 plus 7 becomes 29 upon 2 the whole square. Whole square and the root gets cancelled. Your answer is 29 upon 2 units. Writing units is also equally important. The last answer, very important. The distance between the points W and X is 29 upon 2 units. So here we have seen first question of exercise 5.1. There is an activity also given in the textbook. After seeing this video, I am very sure that you will be writing all the answers of activity by yourself. AB square plus BC square is equal to hypotenuse का square, which is nothing but AC. CB is parallel to x-axis. Check it out. CB is parallel to x-axis. When a line is parallel to x-axis, its y-coordinate is constant. If you have doubt in this, again, please refer to the coordinate geometry of 9th standard in my channel. Y-coordinate of point B is 2. Very good. BA parallel to your y-axis. Any line which is parallel to y-axis has got x-coordinate constant. X-coordinate of point B is nothing but 2. Now you know all the values. You will substitute the values, get the result, pause the video, do the numerical. If you have difficulty, answers are given to you here. Now, if you like the video, please like, subscribe. Thank you for visiting.